Hey guys, today we'll be starting an in-depth look at the Flip Fluids add-on. And in this first video, we're going to go over the fundamentals to get you up and running. Let's get started. If you aren't familiar with the Flip Fluids add-on for Blender, it's a high-quality liquid simulation tool. And compared to the built-in fluid simulator in Blender, this add-on is far more stable and customizable. As of today, I believe it's the single best solution for fluid dynamics in Blender. To get started with the add-on, head over to flipfluids.com. There you can check out release notes, blog updates, and customer reels. And to purchase the add-on, you can click the buy button on the homepage. Here you can see there's a free demo and also 3 locations that you can buy the add-on. Blender Market, Gumroad, and Flip Normals. If you try out the demo and you're satisfied and you want to buy it, go ahead and purchase and download the most recent stable version of the add-on. Now inside Blender, I am using 3.2.1, but definitely refer to your version of the add-on and it'll tell you what version of Blender it recommends. To install the add-on like any other in Blender, click on File, Preferences. Click on Add-on, and then here you can click Install and navigate to the downloaded add-on. Select the zip file and click Install Add-on. Then enable the add-on by clicking the checkbox next to it. And I'm going to save my preferences. Alright, so to get started with the add-on, hit the N key to open up your side menu and click on the Flip Fluids tab. This will open the Simulation Setup tab for the add-on. This has a few of the main commands that we'll be using. Before you can simulate anything, we'll need to create a domain. And as you can see, the Setup tab is reminding us to do that first. This will create a rectangular box or cuboid, which is a fun math term. And this is the necessary shape for Flip Fluid simulations. You can see this better using the grid visualization, that the domain resolution is based on a 3-axis grid layout, X, Y, and Z. And the size of these grids correlates to the resolution of the simulation. The higher the resolution, the more voxels or grid detail that need to be simulated. That will result in a larger file size and simulation time. I recommend keeping the resolution lower as you start curating your simulation, and then increase the resolution near the end of your process. Okay, so where is our fluid? Let's create an icosphere. I'm going to move this up. And you can see in the Setup tab there are 5 other types of objects we can add to our simulation. Let's start with Inflow. Inflow objects are fluid emitters and will create fluid inside their object at a default rate of once per substep. Now, that's once per frame in this case. So let's take a look. Enable auto load baked frames at the bottom of the Setup tab. This will let us preview the simulation as it bakes. And let's hit play. And you can see nothing happens. So that's because the simulation needs to be baked, which is the process of simulating the fluid data and creating a resulting mesh for each frame. So at the top, you can see a bake button. Let's hit that. Hooray! Congratulations, you have created a fluid simulation. Let's hit stop and take a look at what's happening. So by default, the fluid's colliding with the domain volume and the inflow object is acting as like a faucet, pouring liquid into the scene. Pretty cool. Let's reset the bake. That'll delete the baked data. And what happens if we raise the inflow object above the domain? Nothing. And that's because the simulation will only calculate objects inside of the domain. Okay, so now we're going to make a cube with a similar footprint as the domain and leave it at the bottom. This time we're going to set this as a fluid object. And for this test, let's leave the inflow out of the simulation. Now when we hit bake, there's no fluid emitting, but rather the entire cube has become a static amount of fluid, simulating against the domain. This type of object is how you'll start a scene with a body of water or liquid. All right, let's resim and bring this inflow back. And even cooler than before. So now both objects are interacting with each other and ultimately creating one fluid mesh. Let's try something different. We're going to transform the fluid object and place it on one side of the domain. And let's scale down the inflow and move it over here. This time the fluid still interacts with each other, but the fluid object has some momentum as it collapses and then crashes into the side of the domain. Okay, so let's look at outflow objects. I'm going to create one more icosphere and place it to the side. And enable the outflow parameter. Now when we sim, the fluid that interacts with the outflow icosphere is removed or deleted entirely. It doesn't calculate collisions, just removal. And to see this better, let's remove the inflow and run that one more time. So as this simulates, you can see the overall water level decrease as that outflow removes the fluid. Okay, so our next fluid object is going to be an obstacle. I'm going to position this cube here. And enable obstacle. And when we sim, not surprisingly, the fluid is obstructed by this cube. This object type is hugely important in shaping complex simulations, and I definitely recommend you trying it out, having some fun, playing with the settings. Now, best for last, the force object. Let's create an empty object. I'll move it over here and then enable force. By default, this will be set as a point force and have a strength equal to our gravity, which we can see here in the world settings. So if we run this sim, the fluid is pulled by equal force down by the gravity and towards the point force, which makes this diagonal fluid movement. And this is cool looking as the fluid kind of laps around the empty object. Now if we set the world gravity to 0, the fluid moves directly to the point force, and then it kind of fights itself to stay as close as it can to the force. These force object settings are very fun to play with, so once again, try this out, keep learning, and we'll be sure to explore each one of these in a later video. Alright, moving on. Now we're going to create a practical example. Here's a quick look at the final result. It's this sort of swirling vortex of fluid that's been constrained to this globe shape. Think kind of witchcraft or weather device concept, but let's hop in. Let's start with a UV sphere and a cube for our domain. Let's scale that up a bit. And to make sure the sphere interactions are smoother, I'm going to add subdivisions and then apply them. Let's rename this globe and our domain. For our fluid, we're going to create another UV sphere and remove the top half of the faces. And then fill in the shape. Let's scale this in slightly so it doesn't interact with the globe at the start of the simulation. And then we're going to apply the transformations to all our objects. And that's a good idea before any dynamic simulations in Blender. I'll rename this to fluid. And now we're going to assign our fluid objects. Under the physics tab, click flip fluid and set the type of our domain to domain. Set the globe to obstacle, and then click the inverse checkbox since we want the fluid to interact with the interior of the object, and then set the fluid to fluid. All right, now in the flip fluid tab, we will enable auto load baked frames, and we'll turn off the visibility of the globe and fluid objects. And then inside the domain properties, let's go down to the fluid surface category and change our meshing volume to object volume, and then we can select the globe. This will allow the fluid mesh to be created within the globe object and not be creating mesh outside of this globe. And hit bake. So without any forces or inflow, our fluid mesh settles into its globe container. Let's reset and change our timeline duration to 60 frames. And since we want to create a vortex, let's make a curved circle to try as our force object. And let's scale that down and move it up slightly. I'm going to enable the fluid force type, and since it's a curve, the curve guide force mode is enabled with the attraction set to -9.81, same as our gravity. And let's see what this does. So the fluid is pulled towards the curve, and due to the fluid volume, it creates a turbulent donut shape. This is neat, but not what we want. So let's reset the bake and disable the attraction strength, and instead we're going to try the spin strength. Okay, this may have surprised you, but the spin strength creates a directional loop force around the curve shape that will push the fluid to flow continuously in that loop. Again, this is cool, but not the look we want, but the spin is the curve guide force strength we want to use. Let's reset and remove the curve circle and replace it with a curve path. I'm going to rotate this so it is vertical and apply the fluid force type. Let's remove the attraction strength and again use the spin strength and take a look at what this does. Okay, we're getting close. This is a bit too strong, but we can easily adjust this. I'm going to reset the bake and scale this path to the bottom of the globe and disable the end caps function so that the spin force falls off from the ends of the path. And let's lower the spin strength. Now this creates more of a vortex look in the fluid, and this is precisely what we want. Now let's add the whitewater particles. This setting will add foam, bubbles, and spray particles to the fluid movement. There's also a dust particle, but we won't be using that today. There's also particle emission settings and advanced settings that we won't be using today. I recommend you try these out, and I will be exploring these in a future video. So you can see these different particles emitting throughout the simulation. Inside there's bubbles, surface level foam, and then above the surface spray. And we can turn the dust off here since we won't be needing that. And if things are starting to run too slow, you can change your viewport settings here. This adds a nice extra layer of detail to our fluid simulation. Now let's reset again and change our timeline to 180 frames. I'm going to keyframe the gravity and speed of the simulation to give the look of a time ramp to slow motion and then back to real time. So between frames 30 and 50, we'll ramp these values down, and then from 70 to 90, we'll ramp them back up. And I'll apply them to both the gravity and speed settings. And let's take a look. Now that the sim is done, let's play this back. All right, very cool. This is definitely the look I want. My playback speed is a little sluggish. I'm going to change the viewport display to preview to improve the playback performance. That's better. All right, yeah, so you can definitely take this further, but I'm happy with this look, so I'm gonna add a camera. And change the resolution to a square aspect. I'll turn on the globe to make sure I'm centered on the action here. Okay. Now that I have the motion that I want, I'm going to finally turn the resolution up to 120. You'll notice that this sim will take exponentially longer, but thankfully due to editing magic, we can skip the boring parts. With the increased resolution, you can still see the motion is preserved, which is great. And if we turn the viewport display back to final quality, you can see a big change in detail. Yeah. I'm going to jump to frame 40 and add lights and materials. Let's switch to rendered view and change our renderer to cycles, GPU compute, I'm going to change the render samples down to 120. And let's add a sunlight. I'll rotate it slightly. And I'm going to change the color to a subtle teal. And then add a point light just below the globe. Making this a soft purple color. And I'll brighten that up a bit. Now I'm going to add some basic materials. Let's do a transparent water to the fluid object with just a touch of transmission roughness. And then some bluish volume scatter. And for more light detail, let's add an environment texture. I don't want to see this in the background, so I'll enable transparency. And increase its strength as well. And now for the white water particles, let's add a basic white shader to the foam and spray. And then a transparent shader to the bubbles. And then I'll adjust the light intensities. The white water particles by default will render as icospheres, and I'm going to keep that for this simulation. And let's hit render and see what we have. All right, this is looking cool. The particles are a little too large, so let's change those to 0.002, and you can see that that value change applies to all of them. I also want a larger resolution frame, and let's move to a more dynamic part of the simulation for the next render. Excellent, this is looking great. I would like to add motion blur and control these particles a little bit more, but we're going to save that for a future video. For now, I'm happy with the result, and let's move this to the final render phase. And here's the result. In this first part of our Flip Fluid series, I hope you've learned enough to get started with your own projects and just have fun with the add-on. Stay tuned for more of these Flip Fluid series videos. Thanks for watching, and I hope you found this video useful. If you have any comments or questions, please drop them below. And if you did enjoy the video, please consider liking and subscribing to the channel. Stay tuned for more Blender videos, and we'll see you next time.